12, which set of reagents will achieve the following transformation? So we have an alkene, and then we have a bromine and a hydroxyl on the product, and they are trans to one another. So we want to pay attention to the functional groups and to the stereochemistry. So looking at the options, A says MCPBA and Br2. So MCPBA would give us the epoxide, but then instead of a bromide attacking, we have Br2. So that one doesn't really work because Br2 is something that is going to interact with an alkene, not an epoxide. And then some of these other ones, so for example, C, HBr and H2O, we know that HBr is a way to get Markovnikov hydrohalogenation. Then we'll have an alkyl bromide. Water won't be able to react with that, so that doesn't work either. Br2 and hydrogen peroxide, those are the conditions for anti-Markovnikov hydrohalogenation. In this case, it doesn't matter because they're both secondary carbons. That's a way to get a bromine on there, but we also need a hydroxyl on there, so that doesn't work. So it looks like B is going to be the answer. So how does that work? We've got Br2. We know that a pi bond can interact with bromine, kick off the other one. That is going to give us this bromonium ion intermediate. And now, if that is done in water, we can do an SN2 and pop open this three-membered ring right there. It's popping open because there is a positive charge on the bromine. This can attack here, and it will do so via backside attack because it is SN2. Pop that open. That will neutralize the bromine, and then after proton transfer, we do get this situation here. Because it is SN2, that is what gives us this trans relationship on the end here, right? This is anti. It is approaching from the opposite direction that the bromine did. So water attacks, backside attack, pops open that three-membered ring. We get the bromine and the hydroxyl where we want them and the correct stereochemistry. So that will be B.